Hello, this time I'm going to have a look at some level 3 problems in the time response category, so a bit harder than the ones that I've looked at before. First question. Right, here we have a circuit with 2 capacitors and 2 resistors and a choice of 4 different step responses. The first thing to do is to ask yourself what you would expect this circuit to do. And remember, at time t equals 0, just after the step has happened, you could assume that the capacitors are short circuits. And a short circuit here would give you an output there at x, which is 0, because you would have basically a 3K3 resistor here, and then this would be 0 down to ground. So I would expect this circuit not to have an instant step up, but to start gradually, to start at 0 and then move up slowly as one of the capacitors is charging. There's only one of these 4 alternatives that does that, and that's B. All of the others have a distinct step up at t equals 0, so it can't be A, C or D, so without any further ado, B. And I don't need to work out any time constants at all. Often you don't. You can just look at the form of the shapes here, or the form of the circles, apply a bit of common sense, and work out which must be the correct answer. I'll try another one. Okay, this one. You can see it has a step up at time t equals 0, which suggests there is a capacitor between the input A and the output X, and it then decreases down, heading down towards 0. And that suggests that at very long times we're going to get effectively nothing out at all. Now, let's have a look. Well, let's concentrate on how high this initial step is first. It's just over halfway, just over the 500 millivolt mark. So we'd be looking for something that, if we replace the capacitors by a short circuit, remembering that at time t equals 0, all the frequencies operating in the circuits are so high that you can effectively do that, replace capacitors by short circuits. You could say at time t equals 0, then all of these capacitors are short circuits. Which one of these would give you about 530 or so millivolts at the output? Right, first one here. That would give you 15K here, and that would be a short circuit, so you'd end up with 68K going down to there. You would expect much more than about 540 millivolts, so it's not A. This one, B, could be B. B at time t equals 0, you'd have 15K here, and then 22K and 68K in parallel here. And 22K plus 68K in parallel is 16K, so you'd have 15K here and 16K coming down here in the potential divider, which would be just about right. That would actually give me, or predict, a pulse height here of about 1, the input step, times the 16.6K, which is the combination of these components at t equals 0, divided by 15 plus 16.6, 525 millivolts, which is pretty darn close to how big this actually gets. Moving on, it might not be the only one that solves our problem. C, here, unfortunately the same thing would happen. If I replace the capacitor with a short circuit, we'd have 15K, and then 22K plus 68K in parallel, so exactly the same thing would happen, and this would give me the same initial jump as circuit B. But in circuit D, you'd have 15K and then a 4K7 and a 68K in parallel. That's completely different, so no. The answer is going to be either B or C. Now, which one? Well, they differ in what the final value would be. At time t equals infinity, you can replace the capacitors with open circuits. At time infinity, circuit B would essentially become a potential divider with 15k here and 22k down there. That would give me 594 millivolts out at time t equals infinity, which is clearly not what's happening. So it can't be B, it must be C. Hurrah. You can do a lot of them like this, principle of just elimination of anything that clearly doesn't work, leading you the only possibility that does work must be the truth, in good old Sherlock Holmes style. I'll just try one more. Different type of one. Now we've got to build a circuit out of these components with known values which has this step response. Well, clearly we have got an initial spike up to around 760 millivolts here. So we're going to need a capacitor which goes between A and X, but it can't be the only component between A and X, because then the initial spike here would have gone up to 1 volt, and this one doesn't. So let's put a 330 in the way there, and then think about putting a resistor down to ground. Now, we could do this in one of two ways. We could do it here, this way, or we could do it here, this way. But if we do it here, this way, then at time t equals infinity, the capacitor here will effectively be an open circuit, and X there not really defined to be anything. Whereas if we do it this way, at time t equals infinity, the capacitor should have discharged all the way down through this 1k resistor, and that should give us a nice 0 volts output here, which is what it looks like we're getting. So I'm going to say that's right. Hooray! And so on. Hope that gives you sort of the idea anyway.